Hello students. Yesterday we have studied about ammonia reacts with aldehyde. Okay. So which gives aldimine product. So further ammonia react with other aldehydes and ketones we are going to see today. Very important reaction, urotropin preparation. So formaldehyde. What's the molecular formula for formaldehyde? HCHO. One carbon aldehyde is called formaldehyde. So formaldehyde is an important compound. So formaldehyde react with ammonia. It gives some complex structure that is called urotropin. It is also called hexamethylene tetraamine. Right? So formaldehyde. We are going to take 6 moles of formaldehyde. HCHO can be right CH2O formaldehyde. Then we have to take 4 moles of ammonia NH3 4 times. So it will give hexamethylene. Hexa means 6. So 6 CH2 group. You take it. So hexamethylene tetraamine. So 4 nitrogen. So that is a product. Hexamethylene tetraamine. What are the remaining things? 4 into 3, 12 hydrogen, 6 oxygen. So you can write 6 moles of water. Right. So you may not understand how it comes like that because it is a complex structure. We cannot tell what are the shifting and removing and all we cannot write. Okay. But you can write the structure of urotropin. So this having the specific structure N. Here also we have CH2, then CH2, CH2. N, CH2, N, CH2, N, CH2, CH2. So this is the structure of urotropin, right? So this like complex structure will form. It's having another name hexamethylene tetraamine, and also it is called cyclonitride. Okay, so the uses they are given another name cyclonitride. Okay, then what are the uses of this compound? First one, it is used in urinary antiseptic. That means in urinary problem we can use as a medicine. Then as usual it is used in the preparation of a controlled condition. In the controlled condition we can use it to prepare RDX, explosive metal explosive material we can prepare by using this urotropin. And also we have it's having some special name like cyclonitride. Okay, then ammonia also react with acetone. How the ammonia react with acetone? Here we have to take 2 moles of acetone. So CH3, C double bond O, CH3, right? One more aldehyde, sorry, acetone, we can write like this. Now we can take that ammonia, NH2H. Usually ammonia we will write NH3, no. Why I have written NH2H? We are going to remove the 2 hydrogen, that's why. Okay. Write H NH2. So from this 3 hydrogen, you split up 1 more hydrogen. Oxygen, this hydrogen and this hydrogen. First acetone gives oxygen. Second acetone gives hydrogen from the 1 methyl group. Then ammonia gives only hydrogen. So we have 2 bonds here. One bond will connect this NH2 group, another bond will connect with this acetone group. So what is the remaining product? CH3, C, NH2, then already we have one CH3 down. Here there is another group CH2CO CH3. What is the name of this product? 2 acetone we have taken. That's why diacetoamine. What's the name of this compound? 2 acetone is taken in this reaction. That's why we can tell that is 2 acetone. That's why diacetoamine. Then another reaction What's another reaction? Reaction with ammonia reacts with benzaldehyde. Okay. So here we are going to take 3 moles of benzaldehyde. Listen, what's the molecular formula for benzaldehyde? CHO. CH by CHO. You can write C double bond O and H. Another mole of benzaldehyde. CH double bond O. Then one more I am going to write in reverse manner. CH C6H5. Now we have to take 2 moles of ammonia. I am going to write the ammonia like this. NH2H. NH2H. NH3 is the molecular formula for ammonia. Just I am splitting and write. Right? Now this oxygen and hydrogen will go as a water. This hydrogen and oxygen will go as a water. Then this side also, from both ammonia, each one will need one hydrogen, and along with oxygen it will go as a water. So totally 3 moles of water we are going to remove. Now there is a double bond. Directly you can connect with this nitrogen. This double bond you can connect with this nitrogen. But here the double bond, one will form with the first nitrogen at the top, another bond will form with the bottom one. So how do you write the product? C6H5 CH double bond N. It is connected with one of the bond CH C6H5. Then the bottom C6H5 CH double bond N is connected with another bond, the remaining CH C6H5. What's the name of the product, sir? Hydrobenzamide. What's the name of the product? Hydrobenzamide. See, CH and double bond N group comes means we will say amide group. So benzaldehyde is present. That's why we are telling hydrobenzamide. Okay. Then ammonia reaction over. Now we are going to learn about some oxidation reactions of aldehyde and ketones. Okay. So usually aldehyde on oxidation it will give primary alcohol. Very important. Aldehyde on oxidation will give primary alcohol. Ketone on oxidation it will give secondary alcohol. Right. For oxidation we have to use some oxidizing agent. What are the oxidizing agents we can use? Acidified potassium dichromate, acidified KMnO4, alkaline KMnO4. Somewhere we will use nitric acid also for oxidizing agent. Okay. So very familiar, we will use potassium dichromate. We will take one example, CH3 CHO, acetaldehyde on oxidation in the presence of any one of this oxidizing agent. What will happen? Just addition of oxygen, so it will give CH3. Sorry, here I am wrong. On oxidation means aldehyde will give same number of acid. Ketone will give one carbon less acid. Okay, so it will give acid CH3COOH. Reduction only it will give primary alcohol and secondary alcohol. Okay, right. So aldehyde on oxidation will give the same number of acid. That is nothing but acetic acid or ethanoic acid in IUPAC. Ethanoic acid, right? 2 carbon acid. When if you take aldehyde, the same number of carbon will be converted into acid. Suppose if you take ketone, what will happen? Acetone. So ketone, if you take on oxidation, 1 carbon less acid will give. That means it will give 2 or more acid as a mixture. We cannot get the single acid because when the ketone undergoes oxidation, carbon double bond carbon, this bond will undergo the cleavage. So the bond will break. So here any one of this bond from these two, any one bond will undergo the breaking. So because of that, on oxidation, this acetone will give acetic acid and formic acid. That means what? Totally we have 3 carbon where we have the C double bond O, carbonyl carbon. Nearby that the bond will undergo the breaking. Because of that breaking, the remaining 1 carbon acid, formic acid, 2 carbon acid, acetic acid. Likewise, it will give the mixture of acid, not with a single. But here you have to remember, in aldehyde we have taken 2 carbon aldehyde, we got 2 carbon acid. But here 3 carbon ketone we have taken, but we will get 2 carbon acid and 1 carbon acid like. So we cannot get the same number of carbon what we have taken in the reactant. The same number of carbon containing acid will not produce in the ketone oxidation. That is important. Always will get 1 carbon less acid like product. Okay. Then in the oxidation, very important reaction, that is oxidation of unsymmetrical ketone. Okay, CH3, C double bond O, CH3. Now both sides we have only similar group, CH3, CH3. This is called symmetrical ketone. In case one more CH3 is present means we can make it 3, right? So one side CH3 alone, another side CH3, CH2. So unsymmetrical ketone. So C double bond you have to consider as a middle. You have to compare the both side. It is same, we can say symmetrical ketone. Not same, we can say unsymmetrical. Now we are going to take the butane, sorry, pentane. Pentane means we should have 5 carbon. So on pentane oxidation, what will happen? The bond will undergo the breaking. As usual, we know that ketone means the nearby the C double bond O bond will undergo the breaking. Okay. So this bond or this bond will undergo, right? But second condition, according to Pope's rule, we are going to learn Pope's rule. So according to Pope's rule, what is the Pope's rule? First point, the bond will undergo the cleavage. Which bond? Nearby the C double bond O. Second rule, the C double bond O, both sides we have the carbons, you know. We have to count the number of carbon. Which side we have less number of carbon. Along with that, the CO group will go. That is the second point. What is that? The carbonyl carbon goes or give the preference to go along with the less number of carbon present side. Okay. So if you compare this side, we have less number of carbon. So this bond will undergo the breaking. So 2 carbon acid. So 2 product will get, one is 2 carbon acid, CH3COO acid. Then 4 carbon acid, 1, 2, sorry, we should write the CH3 because pentane, I told pentane only, CH3, right? Yes. So 3 carbon means propane. If you take hexanone, that is also correct, no problem. CH2COOH. So propanoic acid. 2 carbon, ethanoic acid, 3 carbon, propanoic acid. Okay, this is also important question. Pope's rule, right? Unsymmetrical ketone on cleavage will give breaking of bond, and also the carbon go along with less number carbon present side. Okay. Now we are going to learn about reduction of aldehyde and ketones. Reduction means as usual we have to use some reducing agent. Very familiar reducing agents are lithium aluminum hydride, another one is sodium borohydride. So lithium aluminum hydride and sodium borohydrides are the important reducing agent. What is in reduction or reducing agent? What is the uses of reducing agent? It will give the hydrogen. So these reducing agents will give the hydrogen. We can add the hydrogen with the aldehyde ketone, so we can reduce that compound. So addition of hydrogen means a reduction reaction. Removal of addition of oxygen means oxidation reaction, right? Okay. Now we are going to take any aldehyde. With any one of these reagent, if you take, it will give 2 hydrogen. Here we can write this aldehyde in the structure, right? There is 2 hydrogen. From this 2 hydrogen, simply you add 1 hydrogen in the oxygen, another hydrogen in the carbon, make it double bond into single bond. Now tell me the product. CH3, already there is 1 hydrogen, one more hydrogen is added in the carbon. CH2, single bond OH, double bond is converted into single bond. So we got alcohol. This reaction only I told. Aldehyde, if you take for reduction, it will give primary alcohol. This is nothing but ethanol. Okay, primary alcohol, because OH group attached carbon having 2 hydrogen. The same way, if you take ketone on reduction, what will happen? It will give same 2 hydrogen. Any one we can take. Then what will happen? See, the same way, the carbon, one hydrogen we can add in the oxygen, another hydrogen add in the carbon, so double bond becoming single bond. So what is the product? CH3 COH CH3. We have one more hydrogen. Sorry, that is wrong. Only CH3. We are going to add 2 hydrogen. One hydrogen here, another hydrogen here. So we have to add one more hydrogen. Now this is becoming secondary alcohol. This is primary alcohol. The second one is secondary alcohol. Actually, what is the name of this alcohol? 2-hydroxy propane or 2-propanol. Okay. Otherwise, we can say secondary alcohol. Secondary alcohol means the OH group attached carbon having only 1 hydrogen, right? Primary alcohol means OH group attached carbon having 2 hydrogen. Based on that, we can tell primary or secondary. Okay. Then, so reduction by using this reducing agent, we have seen. We can use some other reducing agent like the same platinum or some other metal with the hydrogen. This also will give similar product. Okay. Here we have to remember one thing. The lithium aluminum hydride borohydride will not reduce any double bond, triple bond present in the reactor. Only it will reduce aldehyde ketone into primary alcohol or secondary alcohol. Okay. Then another reduction. We have taken lithium aluminum hydride, Now we are going to take some special kind of reducing agents. First one is called Clemmensen reduction reaction. So Clemmensen reduction reaction, we are going to take some catalysts. What are the catalysts? Sodium, mercury and HCl. Okay. Sodium, amalgam and hydrochloric acid is the catalyst for Clemmensen reduction. What is the use of this one? It will give 4 hydrogen. Then the C double bond O group will convert into CH2 group. Previously, lithium aluminum hydride, CO group is converted into OH group, alcohol group. Here CO group will converted into CH2 group. If you take aldehyde CHO with this catalyst, it will give 4 hydrogen. Now, as usual, you write C double bond OH because we can easily learn how it comes like this. 4 hydrogen. You take 2 hydrogen. Combined with this oxygen, it will go as a water. Remaining 2 hydrogen you add in the carbon. Now tell me what is the product? CH3. Already this carbon having 1 hydrogen, additional 2 hydrogen. So again CH3. So ethane, 2 carbon alkane, ethane. If you take, instead of this aldehyde, ketone, if you take, what will happen? The same type of reaction. 4 hydrogen, 2 hydrogen added here, removed as the water, remaining 2 hydrogen added in the carbon. So we will get CH3, CH3, same ethane product. Are you clear, my dear students? Yes. Now, Clemmensen and another one scientist, Wolf Kishner, okay, they are given different catalysts but same pattern of reaction. See here, if you take Wolf Kishner, another reaction, Wolff-Kishner reaction. In that reaction, just you want to take the catalyst hydrazine NH2 along with sodium ethoxide CH3CH2ONA. This is called sodium ethoxide. If you take the same reaction will take place. The same way acetaldehyde will attracted by the react with 4 hydrogen will give ethane, acetone will give ethane. So only the change the catalyst. Okay, the pattern of reaction or mechanism of reaction is same, right? So almost reduction over. The next reduction is phenol formation. What do you mean phenol formation? See, we are going to take 2 acetone, right? The 2 acetone are 2 aldehydes. We can take 2 acetone. The acetone in the presence of the catalyst, special type of catalyst, magnesium, mercury and water. See, catalyst only plays the different product. So you should know clearly what catalyst we are taking here. So this catalyst if you take, you will get phenol product. Okay. So what is phenol reaction? We have to take 2 acetone. For a change you can write. Otherwise you write like this plus C. This is nothing but I have taken 2 moles of acetone. Okay. Then here also very simple reaction. Just addition of 2 hydrogen. Right. So from the 2 hydrogen you add 1 hydrogen in the oxygen, another hydrogen in the another oxygen. Alternatively, the double bond becoming single bond because oxygen added 1 more valency. Now efficiency in this both carbon, so you can make new bond between these 2 carbon. You will get the phenol, right? Listen carefully. You have taken 2 hydrogen. One is added in the first oxygen, another one is added in the next oxygen. Now OH will form. Because of that, the double bond will reduce into single bond. Now carbon having 1 deficiency of a bond, that's why we can make new bond between them. So what is the product? CH3 bond CH3 OH. This is also called 2,3 dimethyl 2,3 dihydroxybutane or 2,3 dimethyl bute 2,3 diol, all IUPAC name. Okay, this also called phenol. Okay, the last one is in the reduction part of it, haloform reaction. This is also an important reaction in the aldehyde and ketones. Haloform reaction. So what do you mean haloform reaction? Addition of halogen, we will get some haloforms. Okay, we may hear about that in movie and all. We will use, if you want to make anybody to unconscious, we will use some spray. What's that? Chloroform. Okay, yes. What's the molecular formula for chloroform? CHCl3, right? So like if you prepare bromine, bromoform. If you use iodine, iodoform. All together we can tell haloform reaction. Halogen we are using. What are the halogens? Fluorine, chlorine, bromine, iodine. If you prepare chloroform or bromoform, iodoform, together we can say that is haloform reaction, right? So we are going to take some aldehyde and ketone. So here we are going to take acetaldehyde with catalyst. Not a catalyst, it is also a reactant in the presence of the NaOH. Among the 6 chlorine, you take 3 chlorine separately, Cl. 3 to 2, 6 chlorine, you know. In that you separate Cl. So now we can remove this HCl. Another, the place of 3 hydrogen, you can substitute this chlorine. Now you will get CCl3, C double bond OH. Further, react with sodium hydroxide catalyst. Simply you remove the chloroform. What's the molecular formula for chloroform? CHCl3, CHCl3. You will get CHCl3 chloroform. What's the remaining? HCOONA. Okay, sir. Sir, book they are given here CH3. If you take aldehyde, you will get sodium formate. If you take acetone, here you will get sodium acetate. That's all. Any one salt of carboxylic acid you will get, but here you will get chloroform. That's why we can say this is a haloform reaction. So we have completed almost all the basic reactions of aldehyde and ketones. Now we are going to learn about some mechanism, important mechanism based on benzaldehyde, aromatic aldehyde. We have discussed many aliphatic aldehyde and ketones. Now we are going to write some chemical reactions on aromatic aldehyde, that is nothing but benzaldehyde. What's the molecular formula for benzaldehyde? C6H5CHO, right? Before that, even the aliphatic aldehyde, we have one familiar condensation reaction. What is that? Aldol condensation. So this aldol condensation also important reaction. We are going to learn the mechanism of aldol condensation reaction also. What is condensation? Just addition reaction, but it may relieve or it may not give any small side product. Okay, just addition reaction, but smaller like water or CO2 gases may go out. Okay, condensation means addition. Aldol means addition of aldehyde and aldehyde is converted into alcohol. So the one compound will form. That compound in this reaction having both aldehyde functional group and alcohol functional group. That's why we are calling that is aldol. See aldol. How will you prepare? How will you separate aldehyde and alcohol? Okay, right. We'll go to the reaction. We are going to take 2 moles of acetaldehyde. Here, what will happen? Alpha hydrogen will go the transformation. Okay, one of the compound will transfer alpha hydrogen to another one, then they will bond themselves. We will get the aldol product. What will happen? This CH3 you can split into CH3H. Then you add in the oxygen. So CH3 CHOH. Then carbon carbon new bond will form in the presence of base NaOH. CH3 CHOH CH2 CHO. Right? If you are not clear, you can write like this. Right? This hydrogen is added here, so double bond will reduce. Then this carbon having a new bond. This is only called aldol. Otherwise, we can tell 3-hydroxybutanol because aldehyde, you know, third carbon having OH group, 3-hydroxybutanol. Now we are going to learn the mechanism of this aldol condensation. How the product is formed. We have 3 steps. Mechanism of this reaction. Step 1. What's the step 1? Removal of alpha hydrogen by base. Right? Step 1, we are going to removal of alpha hydrogen by base. See, we must know what is alpha hydrogen. Yes, the functional group, for example, C-double-bond-O group present means the adjacent carbon only called alpha hydrogen. Very important. Sorry, alpha carbon. Listen, my dear students. Functional group CHO or ketone it may be. So you just remember C-double-bond-O group. Nearby or any carbon directly attached to that carbon is called alpha carbon. Any hydrogen present in the alpha carbon, we can call it alpha hydrogen. Right? The same way we are going to remove the alpha hydrogen. So you take from 2 acetaldehyde, one of the acetaldehyde we have to take it here. Right? Now the CH3 you can write CH3 and H. Why? We are going to remove the alpha hydrogen. functional group attached carbon is called alpha carbon. These three hydrogens are called alpha hydrogen. One of the alpha hydrogen we are going to remove by base. This OH minus will attract this hydrogen becoming water. So this bond will go as a minus. So we will form carbanion. Carbon with minus ion is called carbanion. Okay. So this carbanion will attack as a nucleophile to the another acetaldehyde. In the reaction we have taken two acetaldehyde. One will form carbanion. So another one, step 2. What is the step 2? Nucleophilic attack, or we can say carbanion attack. Then what will happen? Alkoxide will form. How? You have to take another aldehyde, then the carbanion in the first reaction. Our first step we got the product, that is only I have written. This one, from the two, one taken the first step, another one I am taken the second step. Now what will happen? It will attack the carbonyl carbon. This bond will go as a minus. So you can write the product CH3CO minus, then there is hydrogen CH2CHO. The last step, step 3. What is the step 3? Transfer of proton by water. So that same product what we got from the second step, we have to take it for third step. CH3CO minus H CH2CHO plus we have to add the water, right? So water will ionize H plus OH minus. This H plus will form bond with the O minus. So we will get the product CH3COH H CH2CHO. This is nothing but our aldol product. Okay, so this is called the aldol condensation reaction. Mechanism of aldol condensation we have finished, right? Next we are going to learn about some crossed aldol condensation. What do you mean crossed aldol condensation? If you take similar aldehyde for the condensation or similar ketone, if you take it for condensation, that is called aldol condensation. Dissimilar aldehyde or dissimilar ketones or one aldehyde, one ketone, if you take it for condensation reaction, that is called crossed aldol condensation. Crossed aldol condensation. Crossed aldol condensation means one